Hi guys, just been a while since we did anything on Dogen, so I thought I would kick things off with a video, a bit of live coding I guess. So just to summarize where we are, we had a bit of a break, a lot to do with this COVID and all these summer activities and all sorts of stuff going on. So I thought I would just take some time off from this work just to get things under control. But now that we're getting to September, finally time is being freed up a little bit. So we're halfway to a sprint at the moment. If you have a quick look at where we are in terms of GitHub. Not a big fan of this new GitHub page, but yeah, so we released 26 on the 12th of July. So we had July, most of August without really a lot of activity. I mean, there was some activity to be fair. Did half of a sprint, but nowhere as near as much activity we tend to have. So I've been trying to reactivate and get back to where we were. And where we were was, if you remember on the previous sprint, I had that moment of enlightenment where I finally understood that we had a need for a new model, the identification model as is now known. Might not be the best of names, but that's the name for now. And the job of this model is to sort of describe the core entities that describe the logical physical space. In the past, these entities were scattered across the models, and it kind of made sense, to be fair. It made sense because in the physical model, we had entities that described the physical model. So, for example, a name and things like that. And in a logical model, we had things that describe the logical model, and we still do because we haven't got the cleanup hasn't got that far yet. So names, name trees, and things like that. And this was perfectly logical and a perfectly sensible thing to do, except we're now getting to a position where there is a bit of an intertwining between models. So in other words, it's all useful sometimes from the logical space to talk about the physical space, and sometimes from the physical space talk about the logical space. So let's give you an example. Let's imagine you have an artifact. Of course, if you remember, the logical physical space means that as a point in this space, you are one of your axes is in the logical space, the other axis is in the physical space, and that's where the point is. And that point is the artifact. And of course, it's very useful for us to know properties of both the logical and the physical space. So for instance, as an artifact, as you will see here, now I haven't seen this in a little while, so a bit lost, but there shall be a place somewhere where we're describing the artifact. See if I can find it. Oh yeah, the provenance. So the provenance tells us where the artifact comes from. And so as you can see here in the provenance, we have properties here. Well, you can't see because it's an identification, but if I look at here at an identification, provenance, what was the name of the type again? So logical provenance. The logical provenance will then have properties such as the logical name, a logical metaname, and some injection properties. So as you can see, we're kind of drilling across all these different layers. Of course, what you don't really want to do is you don't really want to make a fat dependency between the physical model and the logical model, because that would not be a very good idea, because then, if you remember, and you can read a blog post about this, you don't really want to create loops or cycles in the design. You don't really want to create a point where the logical model depends on the physical model, and the physical model depends on the logical model. Because whenever you do that, you just break testability. I can't now test the logical model independently of the physical model. And if you read people such as Lakos, I'm not sure how to pronounce his name properly, it talks a lot about cycles in the physical design and the logical design. It's very important not to get into those tricky situations. So anyway, to simplify a very complicated case, what we end up doing is we end up extracting all of the things that were in common between a bunch of models, and as it turns out, almost all of those things were related to the identification of meta-model and model elements. Hence why we call this identification. I mean, I probably could have called it ident or ID or something like that, but for now, we just decided to be very explicit. It's quite easy to rename afterwards. Trouble is, when we decided to do that, we also decided to be very clever. We decided to start using primitives. So one of the problems we've had thus far is that, well, everything was a string. And if you listen to Kevin Henny, sorry, you would see that he makes quite a lot of jokes about projects where the most commonly used type is string. So therefore your domain is string. That kind of seems to imply that your domain is not very, well, it's very weakly typed really. You're using a strongly typed language, but in fact your modeling is actually quite weakly typed. And that joke kind of hit home when we looked at Dogen. I mean, we had strings all over the place. What does it mean? Well, it means, for example, if you take an ID coming from the injection space, it's very easy to assign that to, say, for example, a logical meta ID or a logical ID. They're all strings, right? So any of them could be assigned to any of them. And those things just result in nonsensical statements, which then become really easy to difficult to figure out what's going on. So anyway, thinking we would be clever, we decided to do two things in once. Now this is a rule that we almost never break in Dogen. We break it and then we always go back to the basics and go back to the beginning. In general, the lesson you should take from this is you should always try to do one thing at a time. As a Unix saying that says best confuse one issue at a time, and that's a very, very important saying. The problem is, by trying to do simultaneously the primitives as well as this moving of types, we now made the codes break quite a fair bit. So what has been happening in the first half of this sprint, if I take us to what we've got here, it hasn't been pushed yet. You see all these temp commits we got here. That's basically a series of commits related to this rename that need to be squashed. The reason why I ended up making all those temp commits is because it was just getting out of hand. I mean, we're changing thousands of files, and then it was almost impossible to see the wood for the trees. So what I end up doing is to basically say, okay, right, jusqu'ici tout va bien, in Latin fashion, and just basically saying, okay, I mean, not everything passes, not all tests are green, but at least we know that we've done something in the right direction, right? And we've done that for a while, and we're on sort of the cleanup number, I don't know, 4 or 5, I guess. You can see each of these cleanups. These have already been committed. The cleanup we're in at the moment is we're trying to move the physical names into identification. And so just to give us a bit of an incentive, I decided to do a live streaming of this, or not live streaming, but a video of it. Let's just create an area here in Emacs with compilation, because you can't really see my compilation window. Let's call it compilation for good measure. Right, so now you're up to speed of where we are. Now what we've done is we somehow, by hook or by crook, we managed to get Dogen to compile. As you can see here, it actually fully compiles, but of course when you try to run the tests it breaks badly, which is expected really. And now the purpose of this video is to try to fix these problems, try to understand why it's breaking and fix the problems. So of course one of our replaces just was not done very correctly. So what we've done is we've taken an example model. I'll show you with the example model. Always choose a small one so that we can isolate the issue a bit quicker. The example model that or the target model, I guess you could call it, that we choose to debug the problem is, sorry, let me just, where was our logical model? Perhaps identification. It's the API model, the Dogen API model, which is a very simple model, as you can see here. And so what we're going to use is that model to try to get Dogen to work again. We enable logging, and we get the same error as you'd expect. And now we can quickly go up to the log and try to understand what's going on. Right, so what we've done is we know that the error is coming just here. Could not find a type group for archetype. And now you can see clearly what the problem is that this archetype, which has a physical meta ID, the meta ID is blank, is empty. And then if you have a quick look, so we just had a look at this dump here in the log file, and if you have a quick look at what we got here, we can see that, well, let's just look specifically for that key actually. So what are we doing again? We're trying to locate a type group for this archetype. Now of course it does no value, it's blank, so something has gone wrong in the population of the archetype. And in here, what are we looking at? We're looking at the archetype properties. So I guess what we're looking for is to try to see if there's archetype properties with a blank value. In this case, JQ interactive tends to be quite good. So you could say things like so let's just go back to the beginning. So we have an array. So let's just say value. No. So we're inside of the array. Oh, sorry, it is case sensitive, I think. And then we probably want, again, let's just go back to the beginning. We want to the key actually, probably. And then the value of that key. Alright, so as you can see here, this actually doesn't look too bad. I mean, one thing that annoys me about JQ Interactive is that once you've done JQ Interactive and you got the right expression, you can't very simply just go and use it. So I always end up having to take the expression I created and then running JQ again. But as you can see here, it actually looks quite healthy, doesn't it? I mean, everything seems to have been populated in terms of the key. So the key is not the problem. So let's look at the code. And let's have a look at particularly this bit here. Which is this guy here. And specifically, let's look at the place where the exception is coming from. Which is... could not find the type group for archetype. So, okay. So what container are we... okay, we know this is the line. And we know it's here. Right, so now we've found our bearings, we know what's going on here. So we are looking at FGS, but we are using this archetype. And the archetype we are using is obtained by the artifact. Right, okay, so we now know that we have an artifact, and the artifact, just double check that we're not saying anything silly here, but so as you can see here we have an artifact set that contains artifacts by archetype, which makes sense. However, instead of using the key, so this could be just a very simple bug really. It's just, but the problem with dealing with the system where you're simultaneously trying to fix things and refactor and so on, is that some of the ideas are half-baked. So I think what's happening here probably is this, I have this notion of a meta name inside of A, and to be clear, A is an archetype, artifact, sorry. It's an artifact. You can see here Emacs in LSP is telling us what we need to know. So it's an artifact, and in here as well, of course. It's an artifact, and the artifact is being dereferenced because it's a pointer, and then we're going to the artifact and asking for a meta name. Now I think what's happening here is that we just run into one of those refactors that we're trying to do. I think we're going to find the element meta names. So an artifact is here, which is meta name. And so both an element and a meta element have a meta name. And no one at this point in time is populating the meta name for the artifact. The reason why that's happening at the moment is because we probably created this property very recently, we just haven't gone around to actually updating it. So let's think about this. The best thing to do is to look at a transform that creates artifacts. Make sure that that transform then populates the right meta name. So perhaps something like the artifact repository population chain, I suspect. Because, well, now we have to reacquaint ourselves with this code, because clearly I haven't touched this in a while. I'm using a really strange mode for diode that sometimes gives me this sort of problems. A bit annoying, to be honest. If you try to get into this folder, see, it seems to be very upset at the moment. Not to worry, we know the name of the transform, which is artifact repository population chain, so physical source types transforms. And then we want this chap here, perhaps. Now let's try to understand what's going on here. So at this point in time, we are already yeah, we've already got the artifact repository population, artifact repository, and we're just basically populating it. So I'm afraid I'm going to have to sneeze now. English weather, I'm afraid. So where are we then? Yes, so the artifact repository population, so that kicks in after the artifact repository has been populated already. So what we really want to know is who is responsible for the creation of the artifact repository. So if we look a level up into our orchestration, which is sort of the top level model, it then goes in sort of orchestrates everything across the different spaces we have. So in here we have a code generation chain, we have a physical model production chain. Okay, that sounds interesting. So we have the injection model being created, and then the text model and text model production chain. So quite likely physical model production chain should give us some clues. So let's have a look. Physical model production chain. Now, interesting, we have a model production chain in the physical space, and then we have one in the orchestration space. I'm actually tempted to look at the physical space first. And that creates a model. Okay, now we have to remember, the word model is used everywhere in Dogen, so it gets a bit tricky after a while. But remember that what we're doing here is we're in the physical space, right? And then in here, what's happening is we're creating the physical model. So at this point again we are already too late. So let's try again what we tried a second ago. Model physical model production. But this time let's just go to the orchestration as we intended in the first place. Physical model production chain. And then here hopefully will give us a clue as to how this physical model comes to be. So as you can see, this is all very predictable. We start off with an injection model, that injection model goes into a logical, then the logical will go to text, and once you got text, here we are, we create the physical model. And that's just the text model to physical model transform. And now, I suspect, let's just do an LSP find definition here. I suspect this chap here, right, there we are. This chap here is where the creation of the artifact set inside of a physical model will occur. And if you look very careful here, we should see where the artifacts are being created. See, there's a physical ID factory. This is the kind of thing we're looking for. Somewhere around here we're going to see an artifact being created. The reason probably why we're not going to see an artifact set being created. Okay, right, this is all coming back to me now. The reason why we're not going to see this is because, again, a bit of hackery going on. We have some temporary code that still exists in the text model, and that already starts to take us to the physical space. So what you'll see here is you'll see that there's an artifact set inside of the text model. Okay, so then this means that we now have to look at the text model and have to see how the text model is generating the artifact set. And that will be probably happening, well, we're quite close to it actually. I think it's going to be the case that there'll be a logical model to text model transform. We try to organize the transforms in a very step-by-step sort of way, so that, well, mainly so that I wouldn't get confused. And it seems to in general work. Now, if we look carefully here, let's just look for artifact. Suspect somewhere around here. Somebody, right, as you can see here, we're already starting to create these element artifacts, which is the pair that joins the two things together. Here's the provenance. And now we're going to start creating the artifact set. In the artifact set, somewhere, we must create an artifact. Bingo, there we are. Now then, the question we have to ask is, what is the physical meta name for this artifact? And that's going to be obtained by this list here. Right, so let's not call this a manifold, let's call this an artifact set. Okay, so just for context, and the reason why we used to call this manifold, but we moved away from it. The idea is that inside of the logical physical space, we have regions, and each of these regions, so if you imagine a point in the logical space, that point in the logical space corresponds to an area in the physical space. So to think very simply, think of a logical model element, say for example, I don't know, say you take entry point, for instance. Here, what you're visualizing, what you're seeing here is the logical model. You're in the logical space. But behind this logical space, when you make a projection from the logical to physical, this single element corresponds to many, many files. It could correspond to a header file, could correspond to a CPP file. You could even project it for the different kinds of functionality, such as serialization and so on. Those are projections into the physical space. And so therefore, all of those projections put together correspond to the artifact set. We used to call this a manifold because the idea was that you would be inside of a region of logical physical space. But it seems like the mathematical metaphor doesn't really carry through correctly. So we decided, because we didn't quite understand exactly what was meant by manifold, we decided not to use that term. But the idea is just that in these regions of logical space, they correspond, or these points of logical space correspond to regions of physical space. And so as we are entering one of these regions now, we are trying to understand what physical elements, what physical meta elements exist in that space. And so what we'll do now is we're going to take a list of these physical meta elements, and we're going to instantiate we're going to create the instances of those elements. Right, so if everything has gone according to plan, and if I go back to my log file, I should now see, as you can see here, these are the entries in the log file. This is exactly what you expect. Let's look at the first one, and if we look at processing, hopefully this will now give us a nice, lovely physical meta name, which is what you want. Now then, what we need to do is to make sure that the artifact right, so now we probably need to create what is a meta name? A meta name is going to be in fact we went here, we went to meta nameable, we saw that was a physical meta name, and the physical meta name is described as, so it's got a physical ID and it's also have a location. Now this location, as I explained before, this is a bit of a work in progress, unfortunately. So as you can see here, the location contains all the different elements of the meta name. Sadly, I don't think we can populate that just yet, because the problem we have is that we have no, that's fine. We have actual meta names. Okay, so sorry, let's just go back to this. Physical meta name. I think there's actually misleading. I think we're calling this a meta name, but it's actually an ID. Let's just have a quick look. The type that we get from LSP. Well, maybe you have to be on the. Just about to show us the type. Bit annoying. It takes a few seconds, but there we are. So that is telling us that. Yes, it's just because we're printing the ID rather than the whole meta name. So I think this is actually as simple as saying that the physical meta name is that. And also one thing you can clearly see here, doing something really silly here, we just have two variables to mean the same thing. So let's just get rid of the PQN. Let's call all of this physical meta name. Now a lot of this code, as you probably undoubtedly noticed, is a bit random. This refactoring is much more complicated than we thought it would be, and because of that, things are taking a bit longer. We ended up having to hack things around a bit. Of course, I could have used the LSP rename, as you probably will tell me, but I didn't. Now, just have to finish mopping things up. Well, let's go back to compilation and let's try to create a new code generator with this fixin. I mean, this is, but without a doubt, not going to be the last of our problems. Logical model to text transform. Missed one. Let's try again. I'm very happy with the latest update. I just did a recent update to Emacs on LSP, and I must say that the latest LSP is quite responsive actually. Emacs is actually working quite well at the moment. Let's see what sort of errors we get now. Ah, okay, this is actually quite good. We went straight to diffs, so that is actually quite interesting. Now then, what is the problem? Right, let's look very carefully at the diffs. There's not a lot of diffs actually. This is a bit surprising. So the code generator is working, just not doing what it was doing before. Now then, as you can see here, what we've done is we manually fixed some of the templates to give us the right results, and now what's happening is the templates are so we fixed the outputs, not the templates, and the templates are generating the code, and the code is of course wrong because we haven't updated the templates. Now, because we're still using the old style models, we still haven't moved to the new style models, which is probably going to take us a while. We are, it's a bit of a nightmare to update templates at present. I mean, this is just what it is, you just have to deal with it, but it is quite painful. So let's look at an example of this pain. What we'll do is we will open up a mustache file and a stitch file to store our templates. We'll also get a couple of modes. Now, interestingly enough, I thought we had mustache already enabled. No, we do. But what we definitely do not have is we do not have. Let's have a look. The poly modes. So if I just do a Emacs Lisp, byte compile and loads, and if we go back to our stitch template, and if we now say please enable stitch mode, now what we need to also say is split mode disabled, because otherwise disabled, otherwise we start trying to do LSP mode on templates, and that's just not going to do anything sensible. Alright, cool. Okay, so now we're set up to actually start doing the work. So what are we trying to do? Let's go back to 5. What is happening here? What we can see is we're looking at a project transform, a Visual Studio project transform, and what we're seeing is we're seeing two things. First, we're seeing is the wrong header being included. That's what we want, but that's what's actually getting pulled in. And we're also seeing a wrong call to the logger. So we need to fix these two things in the template. Now, the first thing we need to do is you need to locate the template. So if I just go back to the text model, and if I look at Visual Studio, so you can now see already start to see why this is really not a pleasant thing to do. Because now I'm going to have to look for model elements. And of course this will be much easier if this is all in a nice text file, but it's not, so it's in a visual diagram. Now we look for a project. Here's that project, and then the stitch template is here. So what we'll do is we'll go up to our stitch template and we'll just paste the template here, and then we need to locate the lines we're interested in. Now this actually looks rather different from what we were seeing a second ago, so let's just make sure. So notice that this is a transform, not the template itself. So if it's a transform, then we're talking about an archetype. And if it's an archetype, then what we really need is this is where we have to think very carefully. So we probably need an archetype class implementation transform. I was halfway to doing something here, so that's why there's different color there. Can't quite remember what exactly it was. It's been a couple of months. Right, so it is not the archetype class implementation transform. So perhaps the archetype class implementation factory. I'm afraid these names are not particularly brilliant. Sadly, I couldn't think of better names. So it is what it is, really. So here we are. So the problem was with the factory itself, it seems. So let's have a quick look at here. Now, if I am right, I would expect to see this header file here in the factory. And lo and behold, there it is. Just have to remember that we're straddling between meta dimensions, right? So it's important not to get confused between the template and the thing that we're going to generate. So this guy wants to be saying that instead of what he's saying at present. So then what we need to do is we need to go back to our compilation error and look for the second error, which is here. Again, if all goes according to plan, we will see the template generating some code for the logger. Now, the reason why we're not going to see that code just straight away is because this is the second type of template, I believe. The logger part is not going to be here. Okay, so we've done that, the fix we wanted to do here. What we do is we paste the template back where it was and save it. And that's the fix for that. Now we look for the second type of template where the logging bit is going to be. And that's going to be one of these guys. And that is going to be our mustache template, which is this guy here, presumably. And then if you look at the compilation error, no, sorry, the diff, the diff is giving us problems talking about a logger. Do we see any loggers here? No. Well, we see a logger, but it's not this particular logger. That's quite interesting. So we're close, but not quite in the right place. We measure, we search the previous template. It's not there either. Okay, so it has to be one of these. We're just not quite remembering ourselves how this thing hangs together. Which is fair enough, because this is very complicated, really. Probably more so than it should be. Presumably it's not a helper. Let's try this chap. As you can see, this is a bit hit and miss. Of course, what we can do, when it gets a bit iffy and tricky like this, one thing we can always do is look at the raw model. So if I just perhaps if I go up to 7, I'm not using 7 at the moment, so let's say we go to projects, models, and if I look for my dia model, this will definitely be on text.cpp, so there's no point looking anywhere else. Now this is the entire model in XML, and bingo, you can see the template here. Now we're not going to change the model directly. I want to know where this is coming from. I mean, of course you could change all these things in the XML, but we found that it's easier to do things from dia sometimes. This is not exactly the simplest of XMLs. Right, here we are. So the name of the class, CPP artifact transform implementation. I thought we were looking at it. CPP artifact transform. Alright, this is very puzzling. I was convinced we were looking at that. Okay, I'm not quite sure what happened there. I thought we were looking at this file. Maybe some paste error? That is exactly where it should have been. So I'm not entirely sure why we didn't see it, but there you go. So there we are. Now then, what we should really be saying is... okay, so it seems... Right, so some kind of confusion going on here. Let's just very carefully try to understand what's going on here. So we wanted to say this, but instead we're saying the below. So I think all we need to do here, take this chap, update this, paste it, save it, and away we go. Now, just bear in mind what's happening here. What we've done now, this is where things require quite a fair bit of concentration. We have a bug with the code generator, it's generating the wrong code. We changed one of the models of the code generator. We now, before anything, we need to regenerate the code generator, because otherwise we will still be generating the wrong code. However, as you can imagine, when we regenerate the code generator, we have a buggy model. So we are in a bit of a loop, if you think about it. So the current version of the code generator contains the wrong templates. The templates are inside of the code generator. When we do a fix, we need to regenerate a set of models. That regeneration of a set of models will be done with the wrong code generator. So the first thing we need to do is to make sure we only generate the affected model. And we go and do that. Now this is probably not going to do something very clever, because if I now go to my Git, probably going to see a lot of differences, as you can imagine. But it is not necessarily the case that these differences are really what we want. So what we'll do instead is we will just stage these differences, go back to compilation, and now let's attempt to build a code generator using these changes. Now, as expected, we're going to have a lot of problems. And that's because, of course, we're building this code generator with the wrong code generator. Now, this happens sometimes with Dogen. You get yourself into a loop where, by trying to fix the code generator, you break the code generator. So what we need to do in these sort of cases, which is really annoying, really, is we need to very carefully look at the diffs and try to see if we can just extract the parts that we really care about, parts that are important in the changes, and ignore a whole lot of stuff that is not important. So for example, you see here, half of these fixes are good fixes. This is the fix we're trying to resolve with the diff, but not all of them. So in these sort of situations, what we need to do is very carefully make sure we are picking up the good fixes and not the bad fixes. So for instance, we are looking for a meta name factor HPP. Apparently that does not exist. Let's have a look what that is. Meta name factory. Right, so this is just basically something we refactored already. Not a problem. So right, so this looks alright, although we seem to have lost the I/O. That's not a good thing, because as you can see here, so this is not a good change, because look what happened here. Before we were including the I/O, that's a good thing, and then we lost it, and we also were doing dot value, which is also a good change. So this is not a particularly good change. Let's ignore that one. That's just a movement. Oh, I didn't really want to grab that guy. Really, what we really want to get here is to locate the templates for archetypes. That's the only thing that's really of relevance here. So if we just skip all of this stuff, which is going to be noise, and look just for one change in types, and there we are. This is the only change that we really care about. Not that one. Not that one. Ah, bingo. This change here is the change that we actually care about. Sadly, it's also mixed in with other stuff that we don't care about. So really what we want is this. Now I think if we pick this up as well, that's going to break things. So let's just take literally just one thing. And as you can see here, this is not exactly how you want to be working. This is very, very tricky. Now what we need to do is, not stash, but we need to commit this code, and then the rest, which we're not too sure about, we can just, well, not that chap, but pretty much everything else. Yeah, pretty much everything else you can just basically say stash index temp. Right, so we just basically create a stash with all this stuff. We don't really know what that means. And what we'll do now is we will attempt again to create a new code generator. Sadly, the compilation might take a little bit longer now because we changed a few things. So what we tried to do is just to isolate the change that was a good change in the midst of a lot of bad changes. Because remember, just to recap what happened there, we have a code generator that's broken at the moment. It's broken because we made some changes to the code generator that resulted in it generating code that's not particularly nice code. We know that, and that's what we're trying to fix. However, remember, the code generator generates a code generator. So every time the code generator is broken and you're trying to fix something, it also generates things that you don't want to generate, the things that are broken, which makes it really, really difficult to fix the code generator, because you want to basically selectively take bits of the code generator generated, and then of those bits, let's just have a good go at this again. Some of the bits are going to be good, some of the bits are going to be bad, and then you have to very carefully go through the bits and try to figure out which ones is which. Right, so now we have a new code generator. Let's see what the code generator says. Let's see. Well, in fact, to be honest, I think I might not even bother with this right now. What I'm going to do is I'm going to go back to the tests, because I know this code generator is broken. So I'm not even going to bother with that. I'm just going to rerun the tests and see what else is broken, because we know for sure there's lots of problems. There's no point in going straight away for a code generator generation over the model. We just want to figure out what's wrong by looking at the diff. Hopefully the diff will be smaller, and then just rinse and repeat, basically. Fix the templates to the point where we get no differences. Because what we've done is, and this is a good approach when you're generating a code generator in general, make first the changes manually to your code. Make sure the code does what you expect it to do, and then look at the diffs between what the code is being generated and the code that should be generated. And then just try to reduce that set of diffs until it gets close to 0. That's when you know the code generator is generating the right code. So let's see how long we got in this video already. 45 minutes, not too bad. Right, so now we're going to the orchestration test, which actually is the test that we're interested in. A whole lot of errors are going to come up, as expected. Looks a bit smaller. Indeed, it's a bit smaller. Now we have different kinds of errors. Okay, cool. So we'll go to the next set of errors. And that's what we're going to be doing until we get to the end of this. Now, so the next set of errors then. Interestingly enough, is still projects. Sorry about that, it's going to be chilly here. So, as I was saying, we have a problem with projects, and as you can see here, we're basically referring to the previous place where the metadata factory existed. We should be referring to the new place. So we just need to rinse and repeat, really. Project factory. Now, it's going to be a factory of some kind, probably implementation, I presume. Let's have a look. See the stitch template. Slap it here. And there you are. This guy here is not the right thing. So the diff is telling us we should be saying this. So we can literally just replace that with this. And the diff is also saying we should be saying this. Now this here we have to be slightly careful because we don't want to do a full search and replace. We want to actually think slightly about what we're replacing. So now this is rather interesting. This is logical. Alright, okay, so I think what we made to replace is this guy here. And I think is just this bit here. So as you can see, this is not exactly glamorous work as such, and it's a lot of times it's very fiddly and boring and repetitive work, particularly when you have to deal with situations such as the one we're dealing with at the moment, where you need to be extremely concentrated in making these changes. But such is the life of a code generator developer. Right, the second problem is still with project transform. Now, I'm not entirely sure what happened here. So project transform. Now, it seems to me as if we didn't take all of the changes we should have. This is one of the problems with this kind of work. It really requires a lot of concentration, because if you lose track of what you're doing, it's very hard to figure out what you're doing. Right, so let's go back to the compilation. So the problem is with project transform.cpp. So it's a CPP file, so it's an implementation file. It's the transform. It should really have been an archetype, really. Right. However, one must bear in mind that archetypes, all they do is they execute a stitch template for that given archetype. So if I look back at what we just saw there a second ago, you see here we as an archetype we don't really do anything. The archetype is basically somebody else already rendered the template for us, and we just take that template. So possibly what's happening here is it the transform? It is the transform, I believe. So you can see here is the transform. So what we really want is to say what is a project? Let's just go back to projects again. It's obviously even harder to do this with streaming because you're talking all the time, which means you're not concentrating as much. Makes it a little bit harder, but right. So let's have a look at this chap. So this is the project transform, as you can see here. And as we said, there is a mustache template as well associated with this. Which I believe is this chap here. And then we're saying I think I know what happened. We did not take the changes to the mustache template. Yes, so sadly, so when we took the changes, when we regenerated the model that was causing us the problems, we didn't take all of the changes, of course, because as I said, we need to do all that manual hackery. And by doing that manual hackery, some of the changes were actually good changes. So I'm just going to get rid of these stashes for now. This is extremely fiddly. I mean, let's try again. So I'm going to generate the text.cpp again. Right, so now again, we just have to be very careful when we look at this diff. Make sure we pick up everything that needs to be picked up. At this time what we'll do is we'll just discard changes that we don't want. So I'm not entirely sure we should not take this change, but let's just ignore it for now. Right, see what's happening here. This is not a good change. Nor is this a good change. Right, so let's just go through all of these changes here. As you can see, this is all going the wrong way. We don't want it to go back to the way it was because of course we're now using the identification model. So all these changes are just bad changes. But in the middle of this confusion shall be a good change, I believe. In theory it should really only be with the archetypes really, but I'm afraid I haven't looked at this code for a couple of months now and it's actually quite fiddly, so part of it maybe is just that we haven't done the best design in the world, but part of it I think is to do with the fact that this is actually quite a complicated thing with lots of recursion, which makes it really tricky. And of course, as with every bit of code, most of the time you need at least a couple of goes to really understand the problem properly. So up to now we got lots of spurious changes that are not what we want. But I think in the middle of all of this, we're going to see we're still going the wrong way. See, a second ago we just went through all of this very quickly, and normally that's what we do, but because we missed something, now we just have to do it very slowly. The other problem with the code generator, of course, is it generates a lot of code, as you can imagine. Actually tempted to make an Emacs macro for this. So yes, a bit quicker. Okay, up to now, nothing particularly special. Problem, of course, is that you see so much of similar stuff that you might just miss the thing you're interested in. So just to recap, all this stuff is basically taking us back to where things were. That's not what we want. We want to use the new model. And really, now is where we're gonna get slightly more interesting stuff. So this is the archetype class header transform, no problems there, no problems here either. Ah, bingo, okay, so changes here. Now, see how tricky this is, right? We don't want that change, we don't want that change, but we want this change. So that's definitely a good one. And these ones, let's get rid of. Now let's go back to our macro. I suspect there is one more change somewhere around here. Which is related to the mustache template. Perhaps I'm wrong. In which case I might have to go back to the drawing board to understand why. On the plus side, as you get closer to the diff, what was that? We just very quickly went through. Hopefully not the thing we're looking for. I think we're getting quite close to the end of the diffs. There we are. Alright, okay, so it seems like I was wrong. Let's just see what happens when we build code generator with this change in. So we seem to have been missing a diff somewhere. Not quite sure where. It is fiddly, I must say. Sadly, working on a code generator is actually not the most of it's not really, most of the time it's not glamorous work really. You think it is because it's such an interesting problem, but in reality half of the time it's very easy to make architectural decisions and to understand things better and so on. But then when it comes to just then convincing the code to go in the direction you want, it's quite difficult. Particularly when you're bootstrapping a code generator, because every time you change the code generator and you break the code generator, then you don't have a code generator to generate the fixed code generator, which is really not ideal, put it that way. And then to get the code generator to get fixed, then it requires all this thinking, quite deep thinking. Okay, yet again a diff set reduced a little bit, but clearly we're still struggling with our physical meta factory. And we're still struggling with this chap here. Now, I think it's time for us to try to address that. Okay, we know for sure that the change is related to our mustache template, because we've done the change to the mustache template. The problem is the code generated by the mustache template somehow is not resulting on the fix that we want. So let's just go back to that mustache template again. What did we get wrong? So templates, well, here's the mustache template. So actually, before we do that, let's go back to the diff again. The diff has got two problems. One is the header file, and the second is this chap here. So for a laugh, let's copy these two bits and go to the mustache template. There's space at the bottom. So the header file is nothing to the mustache template, so that's fine. What about this guy here? Aha! bingo, we did not fix net and end.id value, so this here was not corrected. Right, so that should address at least one of the problems. Now we just actually, to be honest, sadly we're gonna have to do this again because I want to make sure. Again, this is the sort of problems we have on a daily basis around here. Think that we've changed the right thing, only to realize we changed the wrong thing because they're so similar. This is all going to be greatly improved once we move to a text-based representation of models. Sadly, although we know that's the right solution, it takes quite a long time to get to the right place. Right, okay, there we are. So now then, we fixed the template, and now for good measure, let's try to understand where the header file is coming from. Now, I was convinced, really convinced, this was something went fixed on one of these guys here. And it certainly looks rather similar. In fact, it is awfully similar. Okay, so it seems like we fixed it in the archetype transform. Which should have been the archetype class implementation factory. Archetype class implementation factory. Now, just for good measure, let's just have a look. Sometimes one thing we can do is when it all gets really, really difficult, you can just go back to C++, because remember, at the end of the day, code is just generating C++ code, so you don't have to go via the whole code generator that generates code and so on. Just look at the code and see what the code is trying to do, right? So here's one of these generators, and here is the right thing. Okay, so that actually looks quite good. As you can see here, we are pointing to the Dogen identification, so according to this, seems like we should be generating the right code. So I wonder if there's somewhere else. Let's have a quick look. Let's go to 7. Most interesting. So the problem appears to be that the stitch templates themselves are referring to the wrong header file. Now this is exactly the case where I told you a second ago we don't really like changing the XML files. Well, let me just rephrase that. Sometimes it has to be done. So we close that, and so what's happening at the moment is this: the stitch template itself contains an include. Let me just call this Dogen models, and that include is the old world include. You see it here, and there's loads of them. Basically, every single stitch template is including the wrong thing. Now we're not going to be doing this one at a time, even in this world of ours. It's just a silly thing to do. We just have to double check to make sure that we are looking at the right thing. And see, what it's telling me here is, seems about right. The stitch template is including the wrong thing, the stitch template itself. So that being the case, we're going to do a brute force update of the templates. It's not really what you want to do very often, but sometimes there is nothing else for it, so we just want to be very careful at what we're doing here, because a mistake here could make it almost impossible to recover. Okay, so that's looking good. Let's just change all the 83 templates. And then what we do is we go back to Git, and then again very carefully make sure it looks sensible, which it does. So what we're going to now do is we're going to say, okay, regenerate this code again. First, make sure we have the latest code generator. Now we're going to generate that model again. Okay, now let's have a look at what this guy is saying. We still have a lot of spurious diffs. But what we're really looking for, as you can see here, the template is moved. Right, this is a very interesting sort of situation at the moment. So fixes that we put in are not all going in, so there must be somewhere else where we're doing this archetype qualified. Again, let's have a quick look at this. So we're going to have to do a lot of surgery on the models themselves. Right, so you can see where the problem is coming from, right? We thought we fixed all the places where the wrong thing was being called, but in reality we didn't. And because we didn't, we're going to have problems here. Well, we should try to only change the things we've seen in the diff, just to avoid breaking things even further. So let's go back to that diff again. Right, so the first problem is inclusion path. So we'll just look for inclusion path and fix that. The inclusion path is here. Let's just you can see there's a lot of differences. Not inclusion path, not inclusion path, inclusion path. So we'll just very carefully replace this chap here. Okay, now we go back again to our diff, also in full path. Again, very carefully, full path, and we just replace this chap here. And back to the diff. Right, now this addresses a couple of these problems. Right, so what we do then is we say, well, this looks good. Commit this temp 7. In fact, we'll just start calling this temp because who cares? Then we're going to undo all these commits anyway. And then all the other stuff we stash again. And then what we do again is we attempt. Now you see we generated the model. We generate the model again. Okay. Go back to the diffs. Not sure why the Git is not giving me a right, so then we now expect to see now diffs, hopefully. As you can see, we fixed a lot of the problems. Diffs are now order of includes, problems with I/O. Okay, now we finally got to the static one, so we can fix that as well. Go back to our diagram. This is the static one, so quite easily fixed. Order of includes, static one, which we fixed already. Order of includes. Now this this removal of the meta of this guy here is a bit problematic, isn't it? So let's just have a quick look at where do we see the meta name builder. There we are. So before we go any further, let's just make sure we are in the right place. This is happening in a lot of places. Okie doke. Now let's go back to our diff and see if every single case so we don't seem to always need the method and builder, but when we do, we expect the builder. No, actually seems to be only in the facets. Okay, no problem. So let's go back to the diff. Look for the method name builder, but what we want is the facet one. So where are we then? Facet class implementation. That sounds about right. So what we'll do is we'll add another include here. I mean, this is all extremely atypical of how we develop Dogen. To be fair, we don't tend to make these kind of changes normally. These kind of really hard, low-level changes. So you are seeing the most extreme sort of cases. But nevertheless, it's good to see this. Right, so what we're going to do now is we're going to say again, back to our diff, save the diagram. Let's just save this chap here. Oh, also, one thing we did not do is this exception. Well, to be fair, let's just copy the whole thing. So it's obviously not going to find that, but if we take that away, and you can see there's the guy. And what we really want is this guy here. Make sure it's right. That's correct, okay. Right, that should fix the different exception as well. Now then, we can just take this chap. Right, one more time, we just commit very happily. And then yet again we can just stage a whole lot, ignore that guy, and let's just go back to our index again. Right, once more, let's try to regenerate. Okay, now let's look at how bad the diffs look like. It's annoying that we seem to always have these open diffs. Don't know why my Git's now suddenly decided that you should open all the diffs, but there you go. Right, now then. So, what are we seeing here? So we're seeing that the build factor is still incorrect. Right, the reason why the build factor is still incorrect is, and we're going to see this in a second, is you're going to see that some of the transforms need updating again. Again, this should not be very complicated. We just need to do one very simple thing, which is locate the transform. And in fact, it'll be very easy. We're going to know which one is going to be, because it's going to be the one where there's some streaming going on. Bingo. You can see here quite clearly the guy that we're interested in. Just this guy. Everybody else is going to be saying something really silly. Ah, there's another guy doing some streaming. And so basically what we're looking for is any transform where the streaming is taking place. So now the problem of course is the Git is not really helping us, so let's just do a full screen. Noise winner undo. Right, so we don't care, we don't care, we don't care, we don't care. We do not care about any of these guys. All of this is just in effect okay, that actually looks quite good, and then the two ones that I'm interested in are there. So again, let's just commit this, temp, and once more. As you can see, I mean, you probably by now got the gist of this, but it's really not glamorous work. It is just mind-numbingly repetitive, obsessive kind of work. Rinse and repeat once you got the gist of what's going wrong. But of course this is not really what you're going to be doing all the time. I mean, I must stress this. The only reason why this is really this bad, this annoying, is because we are changing the fundamentals of the code generator. Normally, all you'll be doing is you'll be adding in the new template, fixing the template, looking at the diff, changing that one template until it matches your expected output. We are trying to do something a bit different. We're trying to change the entire code generator. So that makes it much less pleasant. Righty, we seem to have missed one of these boost exceptions. Let's try again. That's one, and then apparently there's only one. Clearly must be lying, because I can see in my diff that this did not get updated correctly. Right, so what we're going to start doing now is we're going to start taking some of these changes where they are only concerned with the order of includes, just purely because it makes our life a bit easier. Right, again another interesting point. We fixed, as far as I could see, fixed all of these. Let's double check that we really did fix all of these. No, we did not. As you can see, there's still a whole lot of them. Right, I'm gonna violate one of the rules around here and actually do some speculative changes here. We know for sure that should not be as it is. So we're gonna just look for all these qualifieds. I mean, normally we try to make these changes quite small and incremental and make sure we see them in the diff first, because otherwise if you start messing around and just changing things fairly randomly, you break things and then things become even more complicated. But now I suspect this is the best thing to do. Now what I really am keen on is trying to understand why we're still getting these guys here. There's literally nowhere else. It's probably because of these chaps here. Okay, so again, speculative change. Suspect this is the right thing. Once you start seeing the pattern, this is the other thing as well. Half of this is lots of care and diligence. The other half is, well, you spotted a pattern, there or thereabouts. Right, now we should just generate the code. Let's see what we get. Now remember, we need to generate the generator first in order to get these changes in. Anything that affects exactly these guys here. See, we still have a few here that are not being picked up by the generator. So, right, so we need a new code generator. That's not relevant. That is relevant. That is very relevant. As with before, what we're looking for is any changes that affect the generator. That's where things tend to get really complicated around here. You need to really think in abstract terms. Remember that we're writing a generator that writes generators. So the things we're looking for are not the generated code, but the generated code. So again, we just go for our temp. We could have probably done that as well, but we didn't, so let's do it again. And then we just commit all of this stuff, and then ignore all that stuff, whatever the stash name is going to be. Now we generate the code generator again. I'm not showing you the compilation, but you can see. So again, all we're going to do is just get the code generator up to speed to generate the new generators. Now then, we just use the new code generator. And then we go to the diff yet again. Now then, what do we see in the diff? Right, new diffs actually, interestingly enough. Okay, we can sign off this diff. This is what we want. See there. We can't sign off this diff because that is actually wrong. As is that. As is these two as well. So these still look wrong. Let's do these. That as well. Right, so a number of these are just header movements. So we're just going to take these for now. I mean, we could now try to understand why it is that the header files have moved, but sometimes you have to choose your battles. Here you see the color cases where you have to look very carefully, because they look identical. Could be just a tiny, tiny bug, exactly like you see here. Something happened. We've introduced an extra bracket. And that extra bracket is actually going to cause problems, so you need to understand why that's there. So we will just basically get rid of all the spurious differences that are just making it difficult to see the real problems. So you can zoom in into the actual real differences. So you can see there's a fair number of noise. Oh, that's not what we meant to select. Now where were we? This is another really annoying thing about coding with templates, is that if you make a mistake such as this mistake we just did here, very trivial mistake, adding a brackets too many, could locate it again, this guy here. Of course you can't have any syntax highlighting, so sadly you just make the mistake and then have to find out when you actually get to C++ code. I mean, Emacs, to be fair, Emacs does tell you with brackets what you're doing, but sometimes you just choose to ignore it. Right, so that's that fixed. Now then, as you can see, the diff is reducing, so it's good. Now then, right, what we can do for these sort of cases is, I'm not very strict with my areas in Emacs. Let's just have the model side by side with the diffs. Now that we got down to a very, very small number of diffs. Right, first thing we need to look for is this meta name builder. Somebody is still calling the wrong meta name builder. Right. Probably not the only place, to be fair. And here we are, quite a few of these. So we don't really want to reference the meta name builder, we want to reference the new guy, which is this guy here. Max decided to slow down as well. Right, so that's the first fix. Now we just have to be very careful when you change the meta name builder. Some of these guys require I/O. Right, the facet, so build factory, build is a facet, so it does require I/O. So one thing that annoys me slightly about XML mode is that sometimes, I mean, maybe it's because you're using large files, I don't know. Sometimes it just seems too slow to crawl. And so what I tend to do is, if I'm doing a lot of changes in XML mode, I tend to change it just to basic, plain, fundamental mode, so that Emacs doesn't try to do too many computations. Right, as I said, this is a facet, and that diff there is telling me that the facet also needs I/O, so I'm just going to listen to the diff and just add that there. Now you may ask, why is it that some cases need I/O, some cases we don't need I/O? Well, to be fair, what I tend to do when I'm working on diffs is to try to just forget about the details and just literally focus on the diff. because you can start to make assumptions, and then these assumptions are wrong. And if the assumptions are wrong, then you will take a long time to then fix the assumptions. So best to just not think really too much. Right, so now we know for sure that in every case where there's physical helpers builder, we really mean the new guy. So we don't even have to think too much about these guys. And as you can see already, there's a huge advantage of treating the model as just a text file, isn't it? Because I mean, look at how quickly you can do all these changes without even having to think about it. That's a facet, so we're good. Right, this is a facet as well. The hash facet. We seem to have a problem with IDs as well as the metaname builder. So let's just have a quick look at what this ID is. Can't seem to find it. Ah, yes, because we're looking for the wrong thing. We should be looking for ID. Okay. Then you see that we made a change there to have everything in one line. Is that a good change? I mean, I'm not too fussed. Line 90, well, actually, I'm going to go back to the old indentation, actually. Okay, cool. So we done a whole lot of changes now to the model. In this sort of cases, what we really want to do is take those changes and regenerate the model. Now, because the changes were done to some generators, as usual, we need to locate the generators. You can see them here. And then we need to create a new code generator. Ah, there's also another change here that we didn't pick up. But before I go any further, what we really want to do is, as usual, do a commit, get rid of all of these spurious changes, create a new code generator. Ah, that's not what we meant to do. Sadly, whenever you make a mistake like this, it costs you time, because now you have to go back and sort out your stashes. Right, so now then, we don't really want to generate, we want to create a code generator with the new generated generators. And once these guys are done, then we have a new code generator, then with that we want to generate. And away we go. Okay, now we go back to our diffs. I mean, this is all quite... right, now then, as you can see, what's happening now is we're getting more and more into spurious diff territory. Now look, we added a new line here. Now at this point in time, to be fair, I'm not going to be fussed about these sort of things. I'm going to say, well, I'll take these diffs. Now we added an IO where there wasn't one before. We removed one when there was one. We'll leave that one be for now. This is just order. And again, it's just order. Here we seem to have improved things slightly, and order. Similarly, bug. Here we introduced spurious brackets. Now I did not think we still had any of these left, but clearly we do. So that's a bug. We need to address that bug. It's IO where we didn't have one before. That's the bug. That looks good. Looks good. And this is another reason why you don't really want to introduce spurious differences, because, so for example, here we change the indentation, which is a good thing, but it's also a bad thing, because now we have to be very careful that the indentation is not hiding a difference, a real difference. It's I try very hard not to change the indentation. I mean, we have good solutions for all these problems. We will. Okay, there's another bug. and another bug, and another bug. That's fine. That's fine too. That's fine as well. And that's fine too. So again, we sign off all these diffs, and now we go back down to another smaller batch of differences. Right, this we don't really know why, but once we try to compile, we'll see what happens. This is definitely a problem, which we believe we fixed, and we don't need to regenerate the generator. This we do need to. Right, we have a few of these, and I suspect they're all equally problematic. So what we need to do is, well, first let's try to understand what this thing's doing. Yeah, I think this is problematic, so let's just basically replace each and every one of these. Well, actually, sorry, this has to be done very carefully, actually. Looks the same. Also looks the same. Now you can see why perhaps changing things to use primitives was not such a good idea to have been done as part of the same change, because some of these changes are purely the generation of primitives, which cause a lot of compilation headaches. And of course in the future it will give us the value, but for now we just feel the pain for not a lot of gain. That's why you should always try to break your changes into small, self-contained blocks of work. Right, we don't really need to regenerate the code generator, I don't think, so let's just try to generate the model. Let's look at the diffs. So as you can see, right, so we don't know if that's going to make any difference. So as you can see, now we've gone the other way, really. Certain cases where we didn't really bother to create the primitives, we are now creating primitives. And before, of course, the code was compiling. So I wonder what that's going to do now. So let's have a look. Create a new code generator. So we're taking in two changes that we don't really know. Right, there we are. So, bingo, we broke the code generator. So what's happening now is we are using primitives in some methods, but actually the methods we're calling are not expecting a primitive, so that's breaking. So what should we do? Should we actually fix the methods that we're calling? Sounds sensible, really. Right, so in order to do that, we need to look at our builder. So let's just say we take any of these errors. Choose one of these. Class implementation transform. You can see here builder is not very happy. The reason why, of course, is because of the change we did, where we're creating a primitive. So what we can do is, this is not generated code, so we can just go to LSB find definition, and as you can see, there's quite a few. What we want is the one with the archetype. Righty, here we are. So to make our life easier, we are just going to hack things around a little bit. So an archetype is what is an archetype? Let's go back to our model. And where are we? We are in the Dogen model. So you see, here we are. These are the changes we just did. And so we need to basically support both scenarios of supplying physical meta ID and not supplying physical meta ID. I mean, of course, as you can imagine, this is just now one big gigantic hack, which is fine. I mean, sometimes it's most important to just move forward than it is to get everything perfect in the first go. So what we're doing right now is we're basically saying, well, some of the code we've changed for the archetype to be a real primitive, and some of the code we didn't. So the first thing now is we need to really get the code back into shape that we can, manageable shape, I guess. And the easiest way to do that is basically by saying, for every method where there is an existing method that takes an archetype, we duplicate that, and we take a physical meta ID. And that's what we just did here. And then probably want that to remain constant. Right, see what we're doing here. We're just basically duplicating the existing methods, giving a signature that allows us to have archetypes in it, in the builder. And then we implement these methods, believe it or not, for now, quite simply by delegating it. Now you probably are saying to yourself, why bother with all of this right now? Well, it's because this is sort of a two-step process. The first thing is, let's just get the code to compile, let's get the code generator to generate, make sure all the tests are green, and everyone's happy. Once you've done that, you can easily remove support for the string-based methods, and then see what breaks, literally. And then, for each of the places where it breaks, you just go and fix it. And making it really easy to solve the problem. So see, all we need to do here is unpack the primitive. And it will be exactly the same for each of these. Now it may look a bit strange, but this is an approach we've done many times in the past, and it solves a lot of problems. You just need to fight your battles. You need to choose what battles to fight, and you can't really change everything in one go. I mean, we've already changed too much in one go, to be fair. We should have really not tackled the primitives at the same time. However, this is a common mistake. It at the time looks like a good idea, and then it really ends up not being a good idea. But interestingly enough, we still have a spurious bracket. I'm just going to do a quick hack again. I'm going to just fix that for now. I think we're going to have more of these. So what we'll do is we'll go back to our diff, try to understand if we introduced some bug somewhere. So I think these can be signed off. They look good now that our builder is behaving. Now that requires some thinking. That also requires some thinking. That sounded about right until we noticed that we have spurious bracket yet again. No idea why I'm still getting these, but that's how life goes around here. And what we really want to do is reduce the number of differences. Okay, fine. So now we signed off all those changes to the archetype. We will just go ahead with those. And now this we can't really sign off because this is wrong. We shouldn't really have any more qualified, so let's have a quick look at the model. Here's a couple, so let's replace these with ID. That should solve these two problems. Notice also that we lost an I/O. So what we'll do is, right, transforms.transform, that is a facet, I believe. Let's have a look. So this is a backhand. Oh, actually, no, sorry. Beg your pardon, that's actually a backhand. So we need an I/O here. Okay. That solves that immediate problem, and what we'll do is we'll disregard that diff, and again disregard that diff, and this we think maybe will be a good one because we don't think this is causing real problems. Right, so now we have compilation errors. I believe these compilation errors are probably to do with those spurious brackets. Which, to be fair, we never really got to the bottom as to why we have so many brackets. Let's just have a look. So, this closes that closes that, and that closes that. Oh, that looks good. Sadly, we have a lot of cases where there's 3 brackets, so let's just go back to the drawing board in the brackets business. Okay, we have a new code generator. Let's just generate again. Let's look at the ifs. Right, so what do we have now? Still annoying brackets and annoying qualified. So first thing is, do we need that? Okay, so we need to generate the generators again. Before we do anything else, let's just do that. No point in wasting any time. But you can see, of course, that the difference, the list of differences is becoming smaller and smaller as you go along, which is what you want. So we generate the generators. Now we generate the generator. Regenerate the model. Now look at the differences again. We still seem to have 3 brackets. This is like a virus. Ah, here we are. There's the chap that's causing all the problem. Fine, that's that sorted. We lost an I/O. That is purely ordering differences, and this is 2 brackets. So, right, we lost an I/O. Where do we lose an I/O? This is... Okay, I think this is also backend. Let's have a look. So, backends, transform, have it. Facet, factory, have it. Backend, factory does not have it. That would explain. Okay, so now then, probably will end up with a few problems there. So, well, actually, before anything else, as usual, let's go for a commit, and probably a commit to that too. As you can imagine, once we uncommit all of this, we're going to end up with a massive commit, but such is life. Most interesting. Seem to have committed something wrong. Okay, most peculiar. What did we do to this file, I wonder? Well, let's just run and generate everything. I think we broke something. Here we are. So now then, we lost an I/O. Okay. Okay, so we have 2 cases where we seem to have a broken code generator. Now, of course, there's going to be a problem, as you've probably seen already. That's not what I'm going to do. We have a broken code generator at the moment. So if you try to build a code generator, you'll fail miserably with this error. Right, so one thing we can do here, which is very easy, is to say, well, have we done some changes recently? And we did. One interesting thing you can do in diff mode is you can reverse, and then it can apply the diff, which is pretty cool. Because it saves you a lot of time, really. If you just want to quickly undo something. And as you can see, that could have been the magic. Now then, let's see what we get in our diffs. Sort of, although boring, it becomes quite exciting in the end, really, because oh, would you believe it? We still have 3 brackets somewhere. Okay, that looks good. That looks good too. We are just down to this last 3 bracket incident. Very interesting. Why we still have 3 brackets? Let's try to understand. As I said before, here we are. We still have a case of 3 brackets here. So yet again, we get rid of that. Take the model. Now, because this is just a model change, we don't need to regenerate the generator. We can just regenerate the model. And look, there are no differences. Right, so one more temp commit. Now then, so you may think that we're actually out of the woods, but actually I'm afraid we're not. That was just to get the generator model clean. Now we still have to run the tests. And now what you're going to see is other kinds of errors are going to start coming through. Now I'm pretty sure we just fixed this. Did we not just change this file? Okay. I think I'm having some kind of strange case of deja vu here. I was convinced we had just updated this file. Before anything else, if things like this start to happen, it basically means the code generator is doing something silly. So there you are, that's what it's doing. And physical meta ID is fine, the builder is not so fine. So, right. Normally you should never argue against the code generator. If he's telling you something is normally correct. As much as you may want it to be otherwise. Right, now then, let's just generate a new code generator. In fact, let's not run tests, let's just generate a new code generator. Let's make sure that our model generates cleanly, in other words, no diffs. Okay, we changed the generator, so of course, as you can imagine, we need to regenerate the code generator. Then we have to regenerate the model again. And now, it's only spurious diffs. Okay, yet another commit. And away we go. Now then, we are ready to run the tests. So first, run build. Nothing should happen here of any note. Run the tests, and I expect to see breakages, or at least be issues related to order on other models. As you can see here, these are just ordering issues, and this will probably be on the C# model, is correct. But we must make sure we don't, in the middle of this confusion, introduce bugs. Yeah, these all look good. Now what is this then? Backend in C++ appears to have changed. Right, there is a problem here. So as you can see here, what's happened is we have forgotten to update some model. Presumably this is going to be the JSON models, I suspect. Okay, so what we'll do is we will just convert Dogen.text.cpp.dia over to JSON. And we, as usual, have to indent it. And hopefully now, if I look at the diffs, you will see, well, this is a spurious diff, but you'll see good differences here. Now I'm going to run these tests again. And I'm hoping that what we'll see is a lot of the breaks are going to go away now. Still a few. Now we just have to make sure we are looking at the right model. Physical model. Okay, right, so fine. So, okay, we have to repeat this exercise for a few of these models. So, text.cpp.json, physical.json, not indent, sorry, convert. Dia to JSON, then we indent it. So of course all the JSON models are not up to date, because of course we've been doing a lot of changes to the models. I suspect we're going to end up with a lot of breaks in the JSON models. Just have to repeat this a few times. I mean, I could regenerate all the JSON models, I guess, but now that is very interesting. I suspect we broke the JSON model. Okay, let's just regenerate the JSON model. And let's indent it again. Right. Before we do anything else, I would like to have a look at the inclusions of these models, and I think you're going to find we're missing identification. So if I look at projects, models, dia, and the physical model, and I look for references, so you see we have all of this stuff here. Interestingly enough, we don't seem to have identification in the list of models. Built-in stud boosts tracing variability, Dogen MASD, MASD variability profiles, and then the default profile. That actually looks good, to be honest. That does look good. So that tells me that whatever error we were seeing a second ago was not something silly like that. Something else, probably something silly, but something differently silly. Right, so we're missing a type. Question is in which model? C#.json. Okay, no problems. Go back to our. In fact, we need to convert text.c# .json, and of course we need to indent it, and of course we need to remember to put dots. Now then you'll see the usual spurious errors. Right, let's try to run the test again. You probably will basically at this point say, why don't you just regenerate all JSON models? Clearly we're wasting time, but I'll persist on my whatchamacallit C#JSON. No, sorry, we're looking at the wrong place actually. Orchestration, that's why. One of the problems I have, I'm very OCD. I need to understand. I don't really like fixes if I don't understand a fix. It's peculiar. I think a lot of programmers are like that as well, actually. They prefer to have things continuously break until they know exactly why they're breaking, rather than just create a fix. Now you can see here that we don't think there's any differences in the orchestration model. Differences are all spurious. Just for good measure, we'll check. So built-ins, boosts, stud, Dogen, variability, tracing, injection, logical, text, physical, MASD, variability, profiles, and that is it. So we don't think the problem we're experiencing is actually to do with orchestration. Once more, we try running the tests. See that the orchestration JSON model is a problem, but perhaps something else is wrong. So Dogen.text is the underlying cause. And yeah, I think you'll find that because of our strange attitudes towards life, now you see why the problem was. A lot of people find this strange, computer scientists, because of this need to sort of figure out why things are not working, and our quest for certainty. That's very good. Now you see there's very, very few differences. So what I'll do once more is I'll go back to my diff. I will do a commit just to get rid of these spurious changes. Now, at this point in time, I'm kind of fairly confident that things are more or less working. So what I'll do is I'll generate every single model. I have login on, so it's slowing things down. Right, so what we'll do is just, for good measure, for my sanity, I'm just going to take logging off and redo this exercise. As you see, it's a bit quicker without logging. Now then, what do we have? We have changes that hopefully are all to do with order and minor formatting. So we can quickly sign off all these changes. That's a bit more than just order. So I'll leave that one for later. Everything else can be signed off. Right, so then we commit these guys here. Right, so these ones we're not too sure of. But I mean, it doesn't mean that they're wrong. It just means we don't know. So first thing we do is just try to compile, because if there's compilation errors, they're definitely not going to be right. Well, I don't see any compilation errors. Then if I run all tests, if all tests pass, I'm fairly confident in the code generator, because we're generating a lot of models. No, so we still have problems. Now we seem to have removed some hashes where we didn't expect them, and these are physical physical JSON and product JSON. Right, so I suspect what we need to do here, without getting too complacent, is just to regenerate the physical .dia and product. Oh well, actually the Dogen model, which we call product and tests, and then we just have to indent them. Now you may think that I'm being complacent and not really getting to the bottom of the errors, but I am fairly confident The only reason why we're erroring is because the JSON models are not up to date. So now you can see the physical model is up to date. There's no difference other than the spurious ones. And similarly, the Dogen model too. Right, so my theory was obviously incorrect. Now then, let's try again. Why are we getting errors in JSON models? A model is not up to date. Of course, now when you get to this point, and it becomes a little bit tricky, and you just can't quite figure out what's going on. So this is clearly in the artifacts. On the physical model, so they should have really resulted in a change there. Interesting enough, they're including a file in text, whereas this is physical. I mean, we've done the text model. Very puzzling. Okay, right, so these sort of situations, sometimes you just have to brute force things. What I just did here is generate all the JSON models. Now, I mean, we tried all the easy options, right? So what we'll do first is just to clean up all the mess, models we don't really care about. And now, very carefully, let's just have a look at the models and see their diffs. Right, so here we are. Identification model is not up to date. So what we'll do in this particular case is pick that up. I mean, pretty obvious it would have been identification model if you think about it, given that it's the model that we're changing things in. Of course, this brute force approach results in a fair number of spurious things. Right, okay, now then, we think at this point in time that the test should be very close to going green. I wish this is the end of the identification changes, but actually, sadly, the biggest change of them all is about to come. So there you are, and this is the end of this, the purpose of this video, which was to get this thing to go green. So what we'll do is we'll sign off these changes as well. We consider these to be good because you know it is fine, it's working okay, and we just commit this as temp. Okay, now what we'll notice is, of course, we're done in doing what we wanted to do, which is to get the code generator to go green. In other words, we have now, so just to recap actually, let's just start to recap because there's a lot of stuff going on here, especially if you're not familiar with Dogen, you might not quite understand what we just did. So what we did was, we recently created a new model called identification. We moved a lot of types that were related to IDs to that type, to that model. We've also introduced a lot of primitives to get rid of the strings that we're using all over the place, and replace all those strings with, well, replaced a lot of those strings with these primitives. Both changes resulted in huge amounts of breakage, so quite literally the physical model just stopped working altogether. The purpose of this commit was just to try to get the physical model to use these new IDs and use new names. We moved all the stuff that were implemented here locally and replaced them by the ones that we had in identification. And then we dealt with the fallout because it was a big fallout. And that was this commit. This is the one but last change that we need to do in order to put the identification model in. The next one, which is even going to be much harder, is the logical model. So again, same thing, we have name, we don't have primitives, so we're going to have to go through the similar process as we did for this. So the change is now done, and we know that the change is now done because we managed to get the test to pass and we managed to get the code generator to give us the right result. So now what we can do is we can do a few winner undos until we get back to our... Sometimes I actually get a bit bored of winner undo because you just travel so much in time you can never find what you're looking for. So what I tend to do actually after, when I get a bit bored, I just give up and go back to doing things by hand really. So what we really want is our usual view of Git. And this is the usual view of Git, so I can actually see what's going on. And we should be on our area of Git, which is correct. Now what we need to do is we need to clean this up so we can actually do a proper push. So as you can see here, we pushed all the stuff all the way up to here, but we didn't push this backlog grooming. So I'm just going to uncommit the whole lot. This is quite a painful thing to do normally. Now as you can see, you have a lot of stuff here, but now the good thing is I know that all this stuff is good, so I can pretty much stage the whole lot. This is one of the lovely things about Git, of committing and uncommitting at will, really, is because you can I mean, when I'm at work, of course, most of the time I just use squashing and so on, but here you don't have to even bother with that. So we can now say something like identification, replace names and related types in physical model. Okay, one big fat commit, and that's it. And then we can now say this is our... Oh, actually, while we're here, we probably, just for good measure, we should just go back to Agile and close this chap here. Clock everything. Go back to Git and commit this guy. Here we can just say the usual backlog grooming. And finally, we can now say git ignore dash folder. And as you can see, we had, I don't know, the best part of quite a few commits, whatever that was, and we replaced all of that with a single nice commit. Good measure, we just run the test before we push. They look decent. Bit slow to be fair, but total of 10 seconds. I don't really like tests that take too long, but there you are. And now we just simply go to our master, merge and push. Okay, and for good measure, let's push to Bitbucket and to GitLab. Okie doke. Now, if we go back to this guy here, we should see the commits coming through, and our builds are going to kick off in a second. And so there you are. This is the end of the last change for the identification model, and well, it was quite satisfying in the end, because we've been working on this for a while and we stopped and now we returned. As you can see here, our commits. There's a big gap here in between July the 26th and September the 4th. So we continue where we left off. This is now going to go over to CI and let's see what CI says. And I think that's all for this video. Thanks very much for watching.